This is the kinesiological analysis of a depth jump. The depth jump is a plyometric exercise that is designed to increase explosive power and force production. It can be broken down to two main phases, the eccentric loading phase and the concentric shortening phase. The depth jump is an exercise skill that engages the stretch shortening cycle of the muscles involved. The eccentric loading phase causes the athlete to absorb the momentum and kinetic energy and use it on the subsequent jump. The primary goal is to produce the greatest amount of force in as little ground contact time as possible. The short eccentric loading phase is performed as it increases the output of the concentric jumping phase of the depth jump. Here we see Coach Robert Beltran performing the depth jump for the first time. As you can see, the depth jump requires contribution from multiple joints and multiple muscles in order to perform the stretch shortening cycle required. Proper completion of the depth jump requires activation of both hip, knee, and ankle flexors and extensors. During the downward eccentric loading phase, the muscles that are passively activated are the hip extensors, the gluteus maximus, the gluteus medius, the hamstring complex consisting of the biceps femoris, the semimembranosus and the semitendinosus, and the adductor magnus. The knee extensors, the quadricep complex consisting of the rectus femoris, the vastus lateralis, the vastus medialis, and the vastus intermedius, as well as the posterior muscle group of the lower extremity, consisting of the gastrocnemius, the soleus, the plantaris, the popliteus, tibialis posterior, the flexor digitorum longus, and flexor hallucis longus. These muscles combine to make the motion required at the hip, knee, and ankle joint complexes, as the femur rotates anteriorly as the motion begins with the knee extension. The hamstrings are stretched over a flexed hip and extended knee, becoming passively insufficient. The knee then begins to flex with the tibia first rotating medially and then articulating surface, rolls, and slides posteriorly. A similar motion occurs as the talus moves on the calcaneus, causing dorsiflexion to occur, elongating the Achilles tendon. Now the athlete transitions into the upward concentric or shortening phase of the jump. The same muscles that were eccentrically stretched are now concentrically contracting. The hip extensors of the gluteus maximus, the gluteus medius, and the hamstring complex consisting of the biceps femoris, the semimembranosus, the semitendinosus, and the adductor magnus. The knee extensors of the quadricep complex, including the rectus femoris, the vastus lateralis, the vastus medialis, and the vastus intermedius, and the posterior muscle group, the lower extremity, the gastrocnemius, the soleus, the plantaris, the popliteus, the tibialis posterior, the flexor digitorum longus, and flexor hallucis longus. The inverse arthrokinematic actions occur across the joint complexes now. As the femur rotates posteriorly, the tibia rolls and slides anteriorly, and the ankle performs plantar flexion, with the talus rolling posteriorly and sliding anteriorly, elongating the anterior talofibular ligament. It should be noted as the athlete performing this jump must be in the final phase of the locomotor skill of jumping. The arms should oppose the leg action. This causes the shoulder complex to swing forward in shoulder flexion. This is caused by the anterior fibers of the deltoid, as well as synergistic contractions of the long head of the biceps and coracobrachialis. The humeral head rolls superiorly and glides inferiorly. The action is reversed in the concentric phase with the posterior fibers of the deltoid, the latissimus dorsi, the teres major, the long head of the triceps, and the sternocostal portion of the pectoralis major, causing the humeral head to roll inferiorly and glide superiorly. One of the primary outcomes from performing the depth jump exercise is to engage the neuromuscular pathways, causing the stretch shortening cycle found in the muscle. This is done by engaging the central nervous system to a greater extent, as the shock absorption in the loading phase increases the active muscle's excitability. Another outcome is the neurogenic effect. As the rate of the stretch shortening cycle increases, the premotor cortex learns to anticipate the movement and the shock absorption phase of the jump. This causes the meiotic reflex firing rate to increase. There can be many sources of error while performing the depth jump. One such error is by using an incorrect box height. This increases the amount of force the body has to absorb while performing the eccentric loading phase. The intensity the athlete works at can also be a source of error, as a depth jump is required to be performed at a maximal intensity. This intensity engages the mechanisms involved in the depth jump to the greatest extent. It is also important for the athlete to use the forward momentum in a forward jump, as this more closely represents a type of jump that the athlete will perform in their sport.